Hi, welcome to howtostats.com. In this video I'm going to demonstrate how to perform a multiple regression analysis. I've already uploaded a video that's a brief video based on this analysis, so if you're only interested in watching the real bare bones basic analysis of doing multiple regression and SPSS, you might consider watching that video. In this video I'm going to go into more depth because multiple regression is quite a sophisticated technique and there are a number of features to it. So in this example, I've got real data here, and the data correspond to the same data I did a principal components analysis on, which is the premium discount and percentage associated with 9 listed investment company stocks. So these stocks trade at a particular price, and that price at times deviates from its underlying net asset value, and sometimes it's negative, which gives a negative percentage, as in this case here. But in other times it's positive, like for ARG it's positive. And the question I'm wanting to answer in this multiple regression analysis is whether I can predict the largest listed investment company on the Australian Stock Exchange, which is AFI. I want to use the other listed investment company discount premium values across time from 2003 to 2010. I want to see if I can predict with a high level of accuracy the listed investment company discount premium associated with AFI. Now, these data could be any data so long as they're measured on a continuous interval ratio scale. Now, that's in multiple regression, that's particularly true for the dependent variable, that you want to be an interval ratio scale. That means continuous. But the independent variables in this analysis are also interval ratio continuous variables, but you could include dichotomous variables in a multiple regression analysis if they're the independent variables. So to do this analysis, go into Analyze, Regression, Linear. Now, my dependent variable is only one space for one variable, and it's AFI. I'm going to put that in there because I'm trying to predict AFI's variability in discount premium values across time. Now, the independent variables are all the other remaining listed investment companies, for which there are 1, 2, 3, 4, 5, 6, 7, 8. Now, I'm going to put them into this independent box, and it's block 1 of 1, and I'm going to keep it there. You only use changes. You only use this option of going from block 1 of 1 to block 2 or block 1 of 2, adding another block in hierarchical multiple regression. I am not doing hierarchical multiple regression. I'll do another video for that. This is not hierarchical. This is just plain Jane multiple regression analysis. Now, what you have to note after you include your dependent variable and your independent variable is you want to put into method the method of including or excluding the independent variables in the model. So what we want to do here is build a model with independent variables, but we only want statistically significant contributors to the multiple regression equation. And so now we have to choose one of 4 methods to do so. If we used method enter, which is the default, it would just force all the independent variables into the multiple regression equation, irrespective of their statistical significance. Now, the alternatives, the most popular alternative, I suspect, is Stepwise, and I'm going to choose that now as a method of determining statistically significant predictors in the equation. What Stepwise does, very briefly, is it looks into the correlation matrix and it chooses the independent variable that has the largest Pearson correlation with the dependent variable, and it puts it into a regression analysis, and it's called Model 1. And then it goes back to the correlation matrix and it looks for the next highest predictor of the dependent variable, controlling for variance in the first predictor that was included in the model. And so it does that sequentially. It keeps going back to the basically the semi-partial correlations and looking for the next biggest predictor of the dependent variable. And then once it finds that it has found a non-significant predictor, it stops the analysis. So and I'm choosing Stepwise, which is the most common, but there are a lot of critics that with Stepwise, criticisms and critics with Stepwise, but I